And there's actually a new build out at the moment. Let's see what the release notes are for this one. Fix for continuous rotation. A 3.9, all right. Let's take a look at the release notes. Fix for continuous rotation, servo movement panel. Well, it sounds like we probably want that. So I do want to do save as. I try and save my revisions and my downloads. Easy Builder revisions. Set the date 3/9/19. All right, finished downloading. VR downloads. Yeah, that's not what I wanted. That's fine. Open the folder. Here. Let's install the software. Next, to a complete install. So after downloading and installing the update from today, 3/9/19, which is today, I'm still getting the update that I have a download to update. So when I click on it, it says I've got to, exit before I can upgrade. And it's like, well, yeah, sure, that makes sense. But if I click yes, take me to the download page. Now it takes me to the Easy Robot download. And that download is still dated at 1/26, which is January 26th. So that's the older standard version, or it's the current standard version for Easy Builder. But what I'm running is the Cynthium Easy Builder version, not the Easy Builder version. So I'm not sure why it's doing that right now. That might be a little glitchy notice type thing between beta and the Easy Builder version. It's not I'm sure it's nothing. I'm sure it's a little hiccupy thing. But anyways, I'm running the latest version. I know that with certainty. So I'm going to ignore all this because I don't need it. What I want to load is my project file for my WallE. So I had started to work on that a while back. So here's my WallE file. And I have a servo movement to drive WallE around. I've got some different controls. WallE is using an ioTiny. I've got a soundboard to play sound out of his ioTiny speaker. I should still be connected
to him. Let me bring up my network
And yeah,
connection.
I'm still connected to him. I've got a servo for his right and left arm. I've got continuous servos for his drive motors. And then I've got LED lights for his eyes that can turn on and off. And I've got a servo rotation for his neck.
And then I have a this model WallE had a button here, and I've got this button and this touch button here hooked up. They're both interconnected to the AD and ADC, one of those ports, through a set of resistors to give different values between which button you press, either this one or this one. So the model WallE that I purchased to do my little conversion on, this is not the one that most people convert. Most people buy the ultimate WallE, and I bought this one on eBay. And sometimes when you buy stuff on eBay, the descriptions are a little it's a little hard to tell what model toy you're getting. So all this one said was motorized WallE. It said it had broken arms, which sure enough the arms were not included. So these arms that you see here are originally I was going to 3D print arms. That didn't work out so well for just various reasons. I just had some problems printing them out. So I decided I'll just go old school, and I made these out of wood, and then I just painted them, and then glued on the servo horn, and then you can kind of see that. Let's see if I get a better shot there. That the little micro servo is in there, and then there's a micro servo for the neck to turn his head. And then I have continuous rotation servos mounted underneath for his wheels. So this was one of the smaller WallEs. It was the kind, it wasn't motorized, but originally this had like a metal bar going across, and I think this kind, it had some kind of little mechanism in here that made the head and arms kind of move, but you could also, I guess kids could kind of like manhandle this and push it around and make it interact manually too. So I don't know what the toy did originally, but it's not the one that most people buy and hack and convert, because it's not very big. It's very small. So I don't recommend buying this one, because it was really hard for me to fit everything in here, even buying small servos and even with an ioTiny. It was harder to convert. Everything just barely fits. But it did fit. If not for the ioTiny, a full-size EZB would not have fit in here. I wasn't sure I was going to be able to get the stock back plate screwed back on with all the wires and everything. It's really squished in there, but it fit just barely, and that's kind of all that's important, as long as it fits. So
with the controls, I forget where I've left off here, but the first thing to do is connect to WallE. So we'll do that, and he should be connected now.
LED on the front here, that's just his power indicator light. It's not connected to the ioTiny in the sense of any kind of control or smarts to this light. It's just a blinking LED. It blinks all on its own as long as there's power to the system. So as long as I've turned his power on, it blinks. So that's what that light's doing. From my screen capture here, we've got the buttons for button ADC, and it's showing 0 volts. If Let me bring him up a little bit. He had a set of these, they're really three little buttons. If you can see that, that's like his little control buttons. It's turned into just one giant button. If I press that, it registers a voltage reading, because this is going to the ADC line. Now let's take a look at what port this is set to.
Because there's two ADC ports on the ioTiny, I believe. So this is ADC 0. And it's the only one I'm using. So there's another ADC port open if I wanted to use something else. This one, if I hit it, we get 269 for the volts. And this one, if I hit it, I get like 297, 296.
This one, if I hit it, we get 269 for the volts. And this one, if I hit it, I get like 297, 296. And this one's like 264, 263.
It's a different register in voltage. And I'll try and share with you later on the circuit I used for this, because there are two switches interconnected and then a set of different resistors that as you press the switch, then it sends a different resistor value down to the ADC line, which it'd be kind of like the equivalent of if you hooked up a potentiometer to the ADC line and you adjusted the potentiometer of like up and down. That's what the switches are kind of replicating. If you understand how a potentiometer works, and then you kind of understand how switches work, and if you could kind of picture like two different resistor values touching the ADC line, then you probably kind of get how that works. But I'll try and show that before the end of the video. So let's test his eyes. His eyes are on D0. And another thing I have for most of my robots, I try and make a cheat sheet for different things. Let me show this on the camera.
So this is my WallE nodes. D0 is his eyes, D1 is the neck, D2 is left arm, and I'm not sure if you can see my handwriting there, but I also have values for the maximum range, servo range too, of the left arm, right arm. So his right arm is D3, his right drive motor should be D6, and his left drive servo should be D7. And then I made a note for myself that I wanted to do some kind of comedy routine for him. And then on the other side, I have notes about his wiring diagram for the LEDs in his eyes, because he came with LEDs, lights in his eyes, and I mapped those out to what the wires were and what resistor values I used for that. I ended up using 220 ohm resistor for his eyes. So let's turn his eyes on, and they're very light. I'll make sure you can see they're actually on. Eyes on, eyes off. Alright, so his left arm, and his arms are not like permanently glued on. I can pop them off and pop them back on pretty easily. So these values are relative. The same with his neck too. I can pop that off as well. So
let's first test the neck. move this here. Yep, 180 is about as far as it goes. And 15, yep. And it looks like, let's see, is that center? So that's center. All right, I'll make a note that, let's see. Let's do project add. There's a note thing in here, isn't there? Where is Notepad? Notepad. All right. So neck. WallE JR version with ioTiny. All right. D0 equals neck 115 180 range, and 100 is center. Okay. So there we have that. Okay, very good. All right, now there's the neck. Let's take a look at the left arm. So the left arm is, actually, no, I need to change that. D1 is that. D0 is the LED eyes. D2 equals left arm servo. All right, left arm servo. All right, left arm servo. All right, so that's 180. Well, it seems like I might want the arm to drop down a little bit more than that. So let's put that down there. Well, so I think that's as far. You see that? I don't want the arm to drop down so far that it would hit the treads. So that's as far as I'm going to drop the servo. So that's 180. 161. If we go to center, that's 120. But actually, that's more like center. All right, so it's 180, 61, and then 60. All right, let's try the right arm.
Three. Right arm, servo. Release. Something went wrong. Alright. $24. So it's 162. 24. Right about there. Dude, do you mind? Let's see, what is center? Center is that. Oh, it needs to be higher than that to go down. Right about 135. So 135 is my center value. Okay.
So there's that. Then D4, D5 is not used. D6 equals right, drive, servo, and D7 equals left, drive, servo. Alright, so or hopefully he won't run off the table.
I think this is not correct. Alright, so anything that I do just makes him spin. So that's not right. Obviously I've messed something up.
Something happened with the movement panel here. Alright, let's take it out then. Let's just, sometimes when in doubt, let's just take it out all together. Alright. Continuous servo movement panel. Left drive wheel. Left drive wheel is D7. Right drive wheel is 6. All right. And then close that. All right, so let's try this again. All right, so go in here. This is his right. That was his left. Something's wrong. All right, well, okay. Then let's reverse it. Make that D7. Make this D6. All right. So the left is D6. All right, let's try that. All right. So this is the left. Forward. Stop. Okay. Okay. All right, so the right is D7 and the left is D6. Okay. Save that. Right. Left. Okay, now goodness gracious. All right. Well, all right. Wait a minute. Does that mean... Oh, goodness.
Alright. He's heading that way faster over to the right. This one is faster than that one. So it would stand to reason. This needs raised up somehow. Alright, let's try this again. Maybe not. That definitely made it worse. Alright, so... he definitely kind of veers off just all by himself. He's not the straightest little robot in the world, but... whatever. Oh, that's interesting. Alright, well that's horrible. Just checking to make sure there's nothing mechanically wrong there. I don't think there is.
Alright, that's pretty good. Turn his eyes on, turn his eyes off. Let's double check what I have his wheels listed at. His left is 6, and D7 is his right. D7. Alright, I gotta change that on my written list. D7 is the right. I'm not surprised I got something wrong in my written list. As squished as all his wires were, I'm not surprised I mislabeled something. So we'll save that, and we'll also go ahead and save our file. And let's make sure his speaker still works. To explain how the how I set up the ADC with the two buttons on WallE, I have a button on the front and a button on the back, and they're both connected to the same ADC line on the ioTiny. So if I press the button in the back, I get one reading, and if I press the button in the front, I get a different reading. So both buttons, they're just momentary touch switches. They were the buttons that came with the robot, and I wanted to keep them and utilize them. I really don't know what I'll use them for, but I thought it might be neat to program them to do something to interact with the robot in some way, to give a feedback or something. So I've got that functionality now inside of EZ Robot, but the way I did it is by using the 2 touch switches, and then with resistors, they're both going to the same ADC line. I didn't have to do that with ioTiny. I could have used, some other method. I had a couple more other ports, but I just wanted to do it. And it's a neat way that you can use multiple switches, touch devices, off of one line rather than multiple lines. If you're using multi inputs, you can save some lines that way. So this goes back to some old stuff from my basic stamp days, from an application note from the basic stamp 1, from 1-pin mini switches. So in their application note here, this is their diagram that they used. I've modified it a little bit because this isn't really needed for the with the Easy Robot. You don't really need the capacitor, and it doesn't need to be set up quite like this. This is needed because of the way the basic stamp worked with their technology. Keep in mind, this is different. Like the basic stamp 1 goes back to 1995. So way different technology. And then the coding, the way it was coded to use this circuitry was a little bit different too. But this was actually more of the way that I wired it in. I used a 10K resistor signal line, which is the ADC line here. Then I would have a 1K, and then my switch, and then another 1K, and then my switch, and then I could keep going however many I wanted to. I could keep going on and on and on and on and on. But if I just use 2, and then wherever I stop at, then you loop it back in this kind of little diagram here. Then it loops back and goes back down. So here's another way to do it with a 10K pull-up resistor, and this is kind of your reading here, where you get your switch, and then you're just, this would be one way to do it, where you're just using one switch. A couple of different methods, but that's really all there is. Just using a couple different resistors and intermixing it with the switch, and then you can get multiple readings. And really what you're replicating, if you think about it, what you're replicating is a potentiometer in a way. That's the way I think about it, because you could hit, if you understand what a potentiometer is, it's a variable resistor, right? So a variable resistor, you could hook that up to the ADC line, and if you manually turned like the variable resistor up and down, you'd be able to see the readings here go up and down as you turned the control of the variable resistor up and down. You'd be able to see that go like up and down. That's kind of what you're doing with the switches, only you're setting it to predetermined points. Like when I hit the button, there's one predetermined point, and if I hit the back button, then there's another predetermined point. That's all we're doing. So it's nothing too fancy. It's just, I don't think many people utilize. I don't see anyone doing this. So it's just a technique not many people use.